Question number 19. 200 logs are stacked in the following manner. 200 logs in the bottom row, 19 in the next row, 18 in the row next to it, and so on. In how many rows are the 200 logs placed and how many logs are in the top row? And if you look into the pattern how the logs are arranged, they arrange 220 logs in the bottom row, 90 in the next row, 18 in the row next to it, and so on. That means they are following some pattern. So in this case, I call the number of logs in the first row as the A1. So A1 in this case is 20, and number of logs in the second row given here is 19. Number of logs in the third row is 18, and so on. So in this way they place 200 logs. So how many logs they place? 200 logs they place in a arranged manner. So I call this a total number of logs in the system is Sn equal to 200. And what we have to find out? We have to find out what is the value of n, number of rows. And after this one, in a particular row An, how many logs are left over? In nth row, how many logs are there? Like this we have to find out. Okay. Now, for this to solve this one, we need values like A, I have to find out. I have to find D. Then with the help of this one, I can find N, and from the N, I can find number of logs in the final row we can calculate. So how to find A? A is nothing but the number of logs in the first row, that is A1, that is equal to 20. And next is D. D is nothing but the difference between the second row and the first row, that is A2 minus A1. So in this case, A2 is equal to 19, A1 is 20, and D is equal to minus 1. So now I got the value of A and D. And what I know already in this case is Sn, total number of logs in the arrangement, that is equal to 200. So from this I am going to find N and other things one by one here. First one, since we know the formula, Sn is equal to n upon 2 times 2a plus n minus 1d, n minus 1 times d. And here I am going to substitute the value what I know so far. Sn equal to total number of logs, that is equal to 200. N I am going to find out, so n upon 2, and 2a, just now we found that one, the number of logs in the first row 20. Number of rows we are going to find out, so it is the n as it is, minus 1. D we found there is a minus 1, that is the difference between the second row and the first row, second term minus first row term. So now I further go for this one. It is a n upon 2, 2 20s are 40, plus now minus 1 into n, that is I multiply minus 1 into n. So in this case it become minus n, and minus 1 into minus 1 it become plus 1. So I have the value plus 1. So further I expand this one, that is equal to n upon 2, 40 minus n, because plus into minus 1 equal minus n, then again plus 1. What is the next step we can do? This one is the other side we have 200. So I am going to multiply this 2 to the other side so that I make a form an equation here. So 202 equal to 400, that is equal to n times 41 minus n. 41 minus n. Okay. So expand this one, it became 41n minus n square. And other side we have 400. I rewrite the same thing in the next page, then I will continue the other part here. So 400 is equal to 41n minus n square, or I can form a quadratic equation. So bring minus n square to the other side, it become plus n square, and 41n when you come to the other side it become minus 41n, and plus 400 equal to 0. So this is in the form of ax square plus bx plus c equal to 0, where a is not equal to 0. There is a quadratic equation. Then how to find value of n in this case? So I can find the roots of this quadratic equation. So how to find the roots of quadratic equation? One method is like minus b plus or minus b square root of b square minus 4ac by 2a. That method we can do that one. It will that is easy when C value is less, but in the case what is the value of C? 400. So instead of that method, we can go for factorization method here. So in this case, what is the value of A? A is equal to 1 and the B is equal to minus 41 and C is equal to 400. And instead of going for a quadratic formula, better I go for a factor concept here. So in this case, 1 into 400. That's what I'm doing now. A into C, I'm doing this one. So in this case, I have to find the factors. Okay. And in this case, I may get the value of maybe n1 and n2. I'll get this one. And if you add n1 plus n2, that must be equal to b. So that is the logic behind what I'm going to do now here. So yeah, then we can easily find the roots of this particular equation, quadratic equation. Okay. So now what I'm going to do is I'm going to find the factors of this 1 into 400. 1 into 400 nothing but 400. I start with this 400 here. So that is equal to 400. So start here 400 and whenever you come across a number with the last two digits of a number 0, that is divisible by 4. So you can 4 will be a factor for this. Even is divisible by 2, 10, 5, many factors are there. But I have to go for factorization so that when I add this one, sum should be minus 41. So 4 here and other side we have 100. Okay. Next one, again I go 100 plus 4, 104. Definitely I will not get 41. So now I am going for next case. Further I am dividing this into 4. So 25, 4. It's better to go for like a prime number, but any of 2 will take a lot of time. So better go for 4 here. So 25 and 4. Okay. So now take this 4 and 4. 4 4s are 16. 4 4s are 16. So in this case, I can rewrite this part here 400 and I divide into two part 25 and 16. 4 4s are 16. 25 plus 16, 41. But what I am expecting is minus 41. What I am expecting? Minus 41. So I just change this to minus 25 minus 16. So when I multiply minus 25 minus 16, I'll get 400. Plus 400, I'll get this one. But when I add minus 25 minus 16, I'll get minus 41. So this equation I can write in other form. N square minus 25n minus 16n plus 400, that is equal to 0. Plus 400 equal to 0. Now what I am going to do is I am going to take the first two terms of this equation. That is n square minus 25n. Then after that I am going to take next two terms and compare with the other thing here. So in this case I am going for the first two terms. What is the common here? N is common. So I keep n outside. So n minus 25. N minus 25. Just take the same n minus 25 to the other side. And now compare this n minus 25 with minus 16n plus 400. How many times of minus 16n in n? That is equal to 16 times. So minus 16. So minus 16n gives a minus 16n. Same way minus 16 into minus 25 gives plus 400. So that is equal to 0. So it consists of two different terms. The first one is n minus 25 and the second one is n minus 16. That is equal to 0. So in short, among these two, one must be 0. Then only the result will be 0. Is correct. So in this case, we come to conclusion 1. So either n minus 25 is equal to 0 or n minus 16 equal to 0. Or from this one, what is this one? If n minus 25 equal to 0, what is the value of n? So n is equal to 25. N is equal to 25. Or n is equal to 16. So I have two. Now I am going to substitute these in the formula an is equal to a plus n minus 1d formula. So then we find out number of logs in the particular row. So first I am starting this an. An is equal to, the formula is a plus n minus 1 times d. Okay. So if n is equal to 25, I'm starting the value, we got two different value. So if n equal to 25, what will happen? So a of 25, that is equal to a is 20, number of rows, number of logs in the first row 20, and n in this case I have selected 25 minus 1, d is minus 1. Okay. And in this case d already we found that one, that is the difference between second row and first row. So we have 20 plus 24 times minus 1, 24 times minus 1. So that's equal to 20 minus 24, that is equal to minus 4. See here, minus 4 means what happened? It shows a negative number in number of logs in the particular row. So definitely this is not possible case in the arrangement, because logs are physical quantity. Number of logs in the particular row must be positive one. So automatically n equal to 25 is invalid. So n is equal to 25 in this case is invalid root. Invalid value, you keep this one value for n. Okay, invalid value. Now I am going to the next part here. What is the next one? N is equal to 16. Again I am applying the n value in the formula. An is equal to a plus n minus 1 times d. And a of 16 is equal to a is 20 and n is 16 minus 1, d is minus 1. So therefore I have this one, 20 plus 15 times of minus 1. So that is equal to 20 minus 15. So that is equal to plus 5. So positive quantity is coming. So I can conclude this one. Number of rows to arrange 200 logs is 16. Okay. So you can say is one, number of rows to arrange 200 logs is equal to 16. And in the 16th row, how many logs are there? 5 logs are there. Okay. So in this case, we come to this one, number of logs in the 16th row is equal to 5.